Today we're going to look at adding and subtracting polynomials. And the most basic level I tell my students is your third grade teacher already taught you everything you need to know about adding and subtracting polynomials. And they look at me a little funny. They said, I don't remember doing any of this x squared stuff in third grade. I say, great, go ahead and add 136 and 452 in this space below. Well, they do that on their papers or not because they think it's kind of silly. I write this down. And the handful of them that are looking towards the front of the room will see that, and they'll think that I've lost my mind, and they'll tell me that I'm wrong. And I say, well, why? What's wrong? They say, well, you're not doing it right. Okay, what does that mean? I mean, who's to decide what's right? It's America, right? Freedom, baby. And they say, no, you have to line things up. And I say, well, what do you mean line things up? They tell me, well, you need to put the 6 above the 2, and the 5 goes underneath the 3, and they said the 4 and the 1 have to line up. And again, I ask, why is that important? And eventually somebody in class will say, well, it's important because there's place value. And it turns out that the place value actually matters. When you add the 6 and the 2 together, that's 8, and you've been doing that since kindergarten, but then the 3 and the 5. Remember, this isn't just 3, that's 3 groups of 10. That 3 is a symbol. I can't add the 3 groups of 10 to the 4, which represents 4 groups of 100 together, and have that make any sense whatsoever. And eventually it starts to dawn on them. Just like place value matters, that like terms matter when we add up polynomials. So eventually we agree that 136 plus 452 is 588. And I remind them that they might have had a really good third grade teacher who also pointed out to them that you could think of this problem like this. The 1 and the 4 is 100 plus 400. The 3 and the 5 is 30 plus 50. And then the 6 and the 2. And I remind them that they probably did a handful of worksheets like that, even though they wouldn't remember them because that was like 9, 10 years ago. But once we've established that the place value matters and all we're really doing is combining like terms, then we set off to add polynomials by adding the coefficients of the like terms. And we remind ourselves that like terms have the same variable and the same exponent. And since we've been thinking about third grade and how to add, say for instance, a couple of 3-digit numbers together, and that makes a lot of sense to us, why don't we follow that same pattern? Let's add these two polynomials vertically. 2x to the third plus 4x squared minus x plus 9. And we'll add to that x to the third minus 6x squared plus 5x minus 1. And since they've already thought about keeping place value together, let's keep the like terms together. 9 minus 1 is going to make positive 8. Negative x and positive 5x, that's positive 4x. They've got negative 4x squared, positive 4x squared and negative 6x squared. Combining those gives negative 2x squared. And then 2x to the third and x to the third, 3x cubed. We can also add these horizontally. And in doing so, we're going to go ahead and physically combine the like terms. So if we're adding these two polynomials together, 5x squared and 4x squared, both have the variable x and the exponent 2. They're like terms. I have a positive 2x and a negative 7x. And then a plus 3. So I can combine these two together. 9x squared, positive 2x, negative 7x, negative 5x, and then the plus 3. Similarly, we can subtract polynomials in the same way. We can do that vertically and horizontally. My students historically think that doing this vertically makes a lot more sense. That's the only one really that we'll look at here. We remind ourselves that to subtract something, we're going to add the opposite. Opposite of a number, I'm going to change its sign. To find the opposite of a polynomial, I'm going to change every sign, multiplying by -1. Change the sign of each term. So let's see what that would look like. 6x to the third minus x squared plus 7x minus 12, and we're going to subtract 3x to the third plus 4x squared plus 9x. So 6x to the third minus x squared plus 7x minus 12. I'm going to add to that the opposite of this second polynomial. So negative 3x to the third, negative 4x squared, negative 9x. Combining those, negative 12 is my constant, positive 7x, negative 9x is negative 2x. I have a negative 5x squared and a 3x cubed. A couple of additional examples. If you wanted some extra practice at home on this, you can go ahead and stop the video, run through these, and check your answer. Adding these horizontally. Positive 5, negative 7 gives negative 2. I have a negative 3x and negative 1x. That's negative 4x. 2x squared minus 4x squared, negative 2x squared, 5x to the third. Let's go ahead and subtract here. 3x to the third plus 4x squared plus 7x plus 12. Now adding the opposite. 4x to the third minus 6x squared minus 9x plus 3. Once we've gone and changed each sign, taking the opposite of this polynomial, and then gone and physically showing that we're adding that opposite, stacking these up vertically, I think makes what we're doing here really, really clear. Lastly, let's take a look at an application problem, adding polynomials kind of squeezed into a word problem here. So we're given an excuse to add these two polynomials together. The number of students in thousands enrolled in high schools in the United States from 1990 to 2002 is approximated by these two models. The number of public school students, the growth over that time, negative 3t squared plus 258t plus 281. Private school, high school students, 2t squared minus t plus 1149. So if we were to model those two things, what they're asking us to do is to add these two things together. That would be the total number of high school students in the U.S. So 2t squared minus t plus 1149. So I'm going to have a negative t squared, 257t, quickly to our calculator. 11,281 plus 1149, 12,430. And it says to estimate the high school enrollment in 2000. Well, that's 10 years after we started, so that means t equals 10. So they want us now to evaluate this function when t equals 10. So we get negative 100 plus 2570 plus 12, 430. And we end up with 14,900. And remember, that's in thousands, so we're going to actually add 3 zeros on the end. That's 14,900,000 students enrolled in high schools in the United States in the year 2000.